have done torque and angular momentum. For a particle. And just to give you an idea, I'm again telling you how we define torque. And suppose there is a point, this is the axis of rotation. If I want to calculate the torque of any force, then it is defined as R cross F about a point, or we can say the origin. This, if I want about this axis, then R cross F cos theta, the component of R cross F along the axis, that will give me the torque. And same way we define the angular momentum, moment of momentum. This is about a point, and if we want about an axis, the component of R cross F along the axis, R cross P along the axis, that will give me the angular momentum. Okay, torque is needed for angular acceleration just as force is needed for translational acceleration. And we established a relation also that torque is equal to dl by dt. It is just like F is equal to dp by dt. Just as force is rate of change of momentum, torque is rate of change of angular momentum. Now these expressions were for particle. Now if we have to apply a torque, or we have to find the angular momentum of a rigid body, then how these expressions change, we will see that. Rigid body means a body for which the size and shape are fixed. So when it moves, when it rotates, its size will not change, and same way its shape will also not change. So we can say the intermolecular distance at micro level, intermolecular distance between molecules, that remains fixed, that is constant, and due to which the size and shape of a very solid object can be considered as a rigid body. Now we will take, if a rigid body is moving around an axis, what will be the expression for the torque and the angular momentum of the rigid body. We will also calculate the kinetic energy of such body. I am taking just a random shape of a rigid body, and this is moving around an axis, and this axis is fixed. Okay, axis itself is not moving around any other axis. Okay, so when the rigid body moves around this axis, we have to find out torque. So just think about the different particles of which the body is made up of. M1, M2, M3, and so many innumerable number of particles of which the body is made up of. And when the body is rotating like this, each particle is making a circle. The radius may be different, but all of them are moving on circles, different radius. So I can say even see, if this particle starts one full cycle, and then after one cycle it will reach here, it will reach here, and this will reach here. So how much distance each particle covers in one cycle? 2 pi r. R is different for each particle, so each particle is having different speed actually. Distance covered 2 pi r, time is this, so this is the velocity will be different, because the particle which is having larger path radius is covering large distance, while the particle here, it is covering just a small distance. But all of them are covering the same angle. Omega is same. Each one is covering an angle of 2 pi. So we can say angular velocity for all particles is same, but the linear velocity is different, 2 pi r by t. So anyway, now consider one particle. I'm taking this particle separately. It is covering this path. And we are taking general. Its velocity may change. Velocity is, one is the change in the direction, so velocity is changing. One, its speed may also change. So it will have two acceleration. One radial due to change in direction, and then one may be tangential. So let's calculate the torque due to both. This radial force, how much this is? Radial force along the radius towards the center, centripetal force जिसे बोलेंगे, mv square by r. So m r omega square, right? V is r omega, so I have substituted that, m r square. And what is the torque corresponding to it? 0, because r cross f is r f sin theta. R and F are along the same line. This is the force and R is also along this. So there is no torque. We have discussed it earlier also that if force is acting towards the axis, there will be no torque for it. Another one, force acting tangentially. How much is this force? Force is MA. This is the tangential force. MA. MA is equal to R alpha. This is because of change in speed. So MR alpha. What is the torque for tangential force? It is R cross F or RF sin theta. So R MR alpha and 90-degree angle, tangential R. So MR square alpha. Torque is R cross F, R into MR alpha, MR square alpha. So this is the torque. And what is the direction for this torque? See, this is R, this is F. So R and F. If I use right hand thumb rule, I will find out that my thumb is along the axis. So for each particle it is along the axis. So how to find out the total torque? It means I can add the torques for all the particles. So I can write it M1 R1 square alpha, M2 R2 square alpha, and so on. Alpha is same. We have just discussed that for all particles angular velocity and angular accelerations are same. So if I take alpha common, we have another quantity here, M1, M2, M3, R3 square, and so on. Torque upon alpha is M1 R1 square, M2 R2 square, M3 R3 square, and so on. Now let us see what is the significance of this quantity. We are applying a torque and there is an acceleration produced, angular acceleration. If this quantity is large, alpha will be very small because the product is equal to torque. And if this quantity is small, alpha will be large. So in a way, this quantity is telling us about the rotational inertia. Why inertia? Because if this quantity is less, the acceleration in the body is large, and if this quantity is large, acceleration is less. So rotationally, it is just like mass. in translational motion. When we apply force, the acceleration produced is inversely proportional to mass. Similarly, when we apply torque, the angular acceleration produced is inversely proportional to this quantity. This we call as moment of inertia and is denoted by I. So I is summation mi ri square, moment of inertia. I is hidden. So it becomes now torque is equal to I alpha. So this equation is just like F is equal to ma. For F, we have torque here. For mass, we have moment of inertia. For linear acceleration, we have angular acceleration. So torque is equal to I alpha. But keep in mind this quantity. This is something new for us. Moment of inertia of any body. And it will depend on not just mass, distribution of mass about the axis. So it means if I gave you a ring and a disk of same mass and same radius, then moment of inertia of ring will be greater than moment of inertia of a disk. Reason? Because see, when we calculate I is equal to mr square, all the particles of which the ring is made up of are at maximum distance from the axis. While in case of disk, some particles are very close, so the value of mr square for those particles will be less. And when we add it, it will be less than mr square for all particles here. So this has more moment of inertia than this. Okay, so torque is I alpha. Same way we can work out angular momentum for a rigid body. And here we will assume that the body is moving with constant angular velocity. So each particle is moving in a circle, and if the angular velocity is constant, it means no tangential acceleration, we have only radial. So torque will be 0, so it will be moving with constant velocity. And what will be the angular momentum for each particle? Rp sine theta, and if there is no tangential acceleration, it means velocity is constant, radial and tangent angle 90, angle between velocity and radius is 90, so individual it becomes RMV. And direction again R cross P, so R and P along the axis. For all it will be same. So again we can have just the additions of all these. So it will be M V R, V1 R1, M2 V2 R2 and so on. V is R omega. So M1 R1 is square omega. M2 R2 square omega. Again omega is same for all particles. And if you can recall from the previous expression, omega is constant, M1 R1 is square plus M2 R, this again becomes. So L is I omega. It's again just like P is equal to MV. For linear momentum, we have angular momentum. For mass, we have the moment of inertia. For velocity, we have angular velocity. And I hope you won't find it difficult to find out kinetic energy in the same way. It will come out to be half I omega square. It will be the sum of all half mv square. V is R omega. So each particle will have this one and will be taken common, and m1 r1 square plus m2 r2 square, the addition of all this, that will become I. So half I omega will be that. So at the end, torque is I alpha for a rigid body, angular momentum is I omega, and kinetic energy is half I omega square. So the body is about an axis, at its place only all the particles are moving, just like fan. So kinetic energy will be half I omega square. Center of mass is not moving forward, it is at its own place. So the different particles move around an axis, so half I omega square. This is the angular momentum of the body, and this is the torque if the angular velocity is changing. So that's enough for this class. Thank you.